Hello everyone, and I welcome you all to another video of our stack series, and this video we are going to learn about a very tricky problem called stock span problem. Okay, so the stock span problem is a financial problem where we have series of n daily price quotes for a stock and we need to calculate the span of stock price for all n days. Okay, we span Si of the stock price on a given day I is defined as the maximum number of consecutive days just before the given day for which the price of the stock on the current day is less than or equal to its price on the given day. Okay, so I have a custom example for you. We can understand it better. So initially we don't have anything here, so what would be the span here? One. Okay. Now span basically is that suppose we come around this number 40. Now I have to calculate the number of days from starting index to the end index, which would be like smaller than 40 consecutive days. So this would be smaller, this would be smaller, but this is not. So what would be the span here? It would be current day 1 plus 2 plus 3. Okay, so that's how we have to do it. Okay, so I just told you it would be 3. Here it would be what? 1 only because no smaller element here. What about this? This element itself and this element 2. What about 35? 1 only. What about 30? 30 is also going to be 1 only. Yeah, right. What about 50? 1, 2, 3, 4, 5, 6. So for it is going to be 6. Right. Cool. Now, uh, can you think there's a trick which we are using is that span is basically index of current element minus index of uh, closest greater element on left side. Okay, just remember this thing. Suppose here it is going to index is 0, index is 1, index is 2, index is 3, index is 4, index is 5, and index here is 6. Right. So suppose for here, what is the closest greater element? 60. So put this formula 1 minus 0, 1. And here also put the formula 2 minus 0, 2. Here also put the formula 3 minus 0, 3. Now for 30, which would be the closest greater element on the left? That would be 40. So 4 minus 3, 1. What about here? Closest greater element is 35. So 5 minus 4, 1. What about here? Closest greater element of 50 is 60. So it is 6 minus 0, 6. Okay. So this is what we have to find. The closest greater element of the left. Okay. Now another observation which I want you guys to see here is, suppose I have found the span till like x0 till xi I have found it. Okay. Now I have to find about xi plus 1. What would be the span of it? Right. Suppose till 35 you have done. You have found the span of any element. Now I have to find the span of 30. Suppose it was not 30, it was some random number. Suppose for now let's say it x. So what would be the basically span of x? Suppose if x was smaller than 35, suppose 30 as it was given, so its span is going to be 1. Suppose it is greater than 35 but smaller than 40, so its span is going to be what? 2. Right. And what if it is greater than 40 but less than 60? So its span is going to be what? 1, 2, 3, 4, 5, 6. Okay. And one more thing. Suppose if the span meaning that x is greater than 60, then obviously we'll get a whole things as span, right? So can you observe one thing, that suppose if we are at xi, the only values which we need to find the span of xi plus 1 is xi itself, its previous greater element which is 40, its previous greater element which is 60, and nothing in between. Okay, and we don't need anything in between. So suppose I have made a stack. Okay, here value is what, 35, 40 and 60, and we have their indexes. 35 index is 0 1 2 3 4, its index is 0 1 2 3, and its index is 0. Now we are at index 5, right? Now I'll check if the top element is greater than 35. If it is, then what? We'll simply remove this element. Right. Now we'll come here. If it is, smaller than 40, then what we are going to have span as 5 minus 3 2. But if it is greater than 40, then what? We are going to remove this. We are going to remove this thing. Yes. Now if the element is smaller than 60, then 5 minus 0, that is 5. And if it is also greater than 60, then we can have span as I plus 1, that is 6. Okay. So this is how where stack comes in play. Okay. Now we have talked about how the stack would come in play and what are the values needed to be put in stack. But let's try and code this thing. You may like pause the video, try it on your own. Otherwise, you can just see the code. Okay. So first we need a stack. So let's make our stack. Then we need a vector int answer, which will store the all the spans which we have to initially return. See vector int. Okay. So initially you can just simply push back for the first element, which is it is always going to be 1, and in the stack we are going to insert uh, indexes. So first index is going to be 0. Now we'll run loop from I is equal to 1 till I less than n and I plus plus. Okay. I'm saying while s dot empty is equal to false, which is meaning it is not false, and price of my current index is greater than or equal to price of s dot top. Okay, I am going to do what? I'm going to simply pop the elements, and in the temp variable I'm going to store, if suppose s is empty, then what I am going to print? Simply I plus 1. Otherwise, I'm going to print I minus s dot top. That is what I performed in front of you, right? And you may put the index of the current element and simply push back temp, right? And in the end, simply return answer. Let's compile and run. Hope this thing works. Okay. Okay. My bad. This should be s dot push, obviously. Okay. Our output and expected output are same. Let's try and submit this thing. And submit it. Okay. So I hope you understood what we did here. See, you cannot obviously tell whether this question was of stack or not, right? But by mere observation, we just figured out that this problem is of stack. So the more problems you do, the more you will understand like what data structure would be used at a specific question. So I guess that was it for this video, and thanks for watching. If you have any doubts, please comment it in the comment section, and stay tuned for the next videos.